Which parameter is considered the primary lethal factor in steam sterilization? A. Steam pressure. B. Steam dryness. C. Condensing steam releasing latent heat. D. Chamber humidity. Answer: C. The killing action of saturated steam comes mainly from latent heat released during condensation, which denatures microbial proteins. What happens if air is not fully removed from the sterilizer chamber before steam entry? A. Cycle time decreases. B. Sterilization temperature increases. C. Mixed air reduces steam penetration. D. Biological indicators multiply. Answer: C. Air pockets block steam from contacting surfaces, preventing proper sterilization even if gauges show correct temperature. Gravity displacement sterilizers rely on which physical principle? A. Steam floats above air because it is denser. B. Air is heavier than steam and is pushed out. C. Vacuum suction pulls air inward. D. High-speed fans circulate steam. Answer: B. Gravity displacement uses the fact that steam is lighter than air, forcing air downward and out. In a typical pre-vacuum cycle, how many vacuum pulses are required for proper air removal? A. 1. B. 2. C. 3 or more. D. 10. Answer: C. Pre-vacuum sterilizers normally use multiple vacuum pulses, often 3 to 4, to ensure thorough air removal. The exposure phase of a 270 degrees Fahrenheit 132 degrees Celsius steam cycle typically lasts: A. 1 minute. B. 4 minutes. C. 15 minutes. D. 30 minutes. Answer: B. Most wrapped loads at 270 degrees Fahrenheit require a minimum exposure time of 4 minutes for sterilization. Which device confirms air removal efficiency in pre-vacuum steam sterilizers? A. Bowie-Dick test. B. Biological indicator. C. Chemical indicator class 6. D. Process challenge device. Answer: A. The Bowie-Dick test pack checks for adequate air removal and steam penetration before daily use. What is the recommended drying time for textile packs in a pre-vacuum steam cycle? A. 1 to 3 minutes. B. 5 to 10 minutes. C. 20 to 30 minutes. D. 60 minutes. Answer: C. Textile and heavy sets require prolonged drying to avoid moisture retention and recontamination. What is the role of a steam trap in a sterilizer? A. Holds steam pressure. B. Removes air and condensate. C. Adds humidity. D. Measures chamber temperature. Answer: B. Steam traps ensure condensate and air are discharged so steam can contact load surfaces. Which of the following can cause wet packs? A. Proper dry time. B. Correct wrapping technique. C. Fully dried steam. D. Overloading the sterilizer. Answer: D. Overloading reduces air removal and steam circulation, leading to moisture retention. What condition must steam meet to be effective in sterilization? A. Dry. B. Wet saturated steam. C. Superheated steam. D. Cold steam. Answer: B. Saturated steam with 97 to 100% dryness ensures efficient heat transfer and microbial kill. The most resistant form of microbial life to high-temperature sterilization is A. Gram-negative bacteria. B. Vegetative cells. C. Viruses. D. Bacterial spores. Answer: D. Spores require high heat and moisture for destruction, making them the gold standard for validation. A biological indicator for steam sterilization typically contains A. E. coli, B. Geobacillus stereothermophilus, C. Bacillus subtilis, D. Pseudomonas aeruginosa. Answer B. Geobacillus stereothermophilus is highly resistant to moist heat, ideal for BI testing. Which sterilizer cycle is best for porous loads? A. Flash cycle, B. Pre-vacuum cycle, C. Ethylene oxide, D. Hydrogen peroxide plasma. Answer B. Pre-vacuum cycles remove trapped air, enabling steam penetration into porous materials. A wrapped load at 250 degrees Fahrenheit 121 degrees Celsius usually requires an exposure time of A. 10 minutes, B. 15 minutes, C. 20 to 30 minutes, D. 45 minutes. Answer C. Lower temperature cycles, 121 degrees Celsius, require longer exposure, often 20 to 30 minutes. If a chemical indicator inside a pack fails to change, what must be done? A. Use the item, B. Rewrap only, C. Quarantine the load, D. Reprocess the load. Answer D. Failed indicators mean inadequate exposure, items must be fully reprocessed. Steam sterilizers must be monitored using biological indicators. A. Weekly, B. Monthly, C. Daily, D. Each load. Answer A. Guidelines require weekly biological monitoring, and for implant loads, each cycle. One cause of sterilizer chamber pressure fluctuations is A. Proper maintenance, B. Failed steam trap, C. Correct loading, D. Good gasket seal. Answer B. A malfunctioning steam trap leads to pressure instability and improper steam flow. Implant loads must be released only after A. A passed Class 1 indicator, B. Dryness of the pack, C. BI results are available, D. Technician approval. Answer C. Implants require BI verification before release to ensure patient safety. Which packaging material is least suitable for high-temperature sterilization? A. Tyvek, B. Paper plastic pouches, C. Rigid containers, D. Woven textiles. Answer A. Tyvek is not designed for high-temperature steam and can melt or deform. Wet steam can lead to A. Increased dryness, B. Superheating, C. Corrosion of instruments, D. Shorter cycle times. Answer C. Moisture encourages rust and corrosion, especially on carbon steel items. The greatest challenge for steam penetration inside a lumen device is A. Steam pressure, B. Air entrapment, C. High temperature, D. Chamber humidity. Answer B. Air trapped in lumens prevents steam from entering, making sterilization ineffective. Sterilizer drain strainers must be cleaned. A. Monthly, B. Weekly, C. Daily, D. Yearly. Answer C. Daily cleaning prevents debris from blocking condensate removal. Which cycle is typically used for emergency sterilization of unwrapped items? A. Pre-vacuum, B. Gravity flash, C. Low-temp hydrogen peroxide, D. Ethylene oxide. Answer B. Flash, immediate use, sterilization is commonly performed using gravity displacement. Carbon steel instruments are more prone to rust when exposed to A. Dry steam, B. Superheated steam, C. Wet steam, D. High humidity during storage. Answer: C. Wet steam leaves excess moisture, accelerating corrosion. What is the ideal dryness fraction of sterilization steam? A. 50%, B. 70%, C. 90%, D. 97 to 100%. Answer: D. 97 to 100% dryness ensures effective condensation and heat transfer. Superheated steam is ineffective for sterilization because it A. Contains no moisture, B. Is too cold, C. Is too wet, D. Damages instruments. Answer: A. Superheated steam acts like dry heat, lacking the moisture needed for microbial destruction. A load is considered non-sterile if A. Items cooled naturally, B. CI color changed, C. BI test is positive, D. Exposure temperature is reached. Answer: C. A positive BI indicates surviving spores, sterility cannot be assured. A cold spot in a sterilizer chamber may be caused by A. Proper steam flow, B. Incorrect loading, C. Correct drain placement, D. Using pre-vacuum cycles. Answer: B. Overpacking or blocking steam pathways can create cold areas with inadequate heat. Excessive chamber lubrication can A. Improve steam penetration, B. Cause oily residues on instruments, C. Increase dryness, D. Reduce corrosion. Answer: B. Too much lubricant becomes residue, impacting sterilization and instrument function. The purpose of the conditioning phase is to A. Cool the load, B. Add chemical indicators, C. Remove air and begin heating, D. Release the load early. Answer: C. Conditioning removes air and gradually heats the load before exposure. A sterilizer that reaches correct pressure but not temperature likely has A. Wet steam, B. A faulty temperature probe, C. Overdry steam, D. Proper function. Answer: B. Pressure remains normal even if temperature sensors fail. Wrapped sets should be placed in sterilizers: A. Tightly touching, B. With space for steam circulation, C. Face down only, D. In sealed bins. Answer: B. Space ensures steam access and effective drying. Chamber gaskets require replacement when A. Steam leaks are visible, B. They appear dry, C. They feel warm, D. They change color. Answer: A. Visible leaking or pressure loss indicates a failing gasket. A sterilizer load sticker that turns dark prematurely indicates A. Correct exposure, B. Overheating, C. Chemical contamination, D. Indicator malfunction due to moisture. Answer: D. Moisture or improper storage can cause false CI reactions. The cool-down phase prevents A. Instrument corrosion, B. Rewootability from condensation, C. CI failure, D. Overexposure. Answer: B. Controlled cooling avoids condensation, which can cause wet packs. Biological indicator challenge packs are required for A. Pre-vacuum cycles only. B. Every load. C. Implant loads. D. Flash loads. Answer: C. Implant loads demand BI-verified sterility. Dry time failure may indicate A. Correct loading. B. Excessive textile weight. C. Proper airflow. D. High dryness fraction. Answer: B. Heavy textile loads retain moisture and prolong drying time. In steam sterilization, conditioning is also called A. Exhaust. B. Exposure. C. Come-up time. D. Holding. Answer: C. Come-up time equals conditioning, where air is removed and heat rises. Sterilizer chamber filters should be changed. A. Daily. B. Weekly. C. Monthly. D. As recommended by manufacturer. Answer: D. Filter schedules vary, follow OEM guidelines. The first step if a BI test is positive is to A. Report and recall items. B. Ignore and continue. C. Reprocess only BI pack. D. Shut down the facility. Answer: A. Positive tests require immediate recall and retesting. What does a Class 5 integrating indicator measure? A. Pressure only. B. Time and temperature only. C. All critical parameters of a cycle. D. Biological activity. Answer: C. Class 5 indicators monitor time, temperature, and steam quality. The minimum steam sterilization temperature for wrapped loads is A. 200 degrees Fahrenheit. B. 212 degrees Fahrenheit. C. 250 degrees Fahrenheit. D. 170 degrees Fahrenheit. Answer: C. Standard steam cycles start at 250 degrees Fahrenheit 121 degrees Celsius. Hard water deposits inside a sterilizer can lead to A. Better heat transfer. B. Sensor malfunction. C. Reduced corrosion. D. Less maintenance. Answer: B. Mineral scale affects temperature sensors and cycle performance. Which instrument is most vulnerable to corrosion during wet cycles? A. Titanium instruments. B. Stainless steel instruments. C. Carbon steel instruments. D. Aluminum handles. Answer: C. Carbon steel corrodes easily when moisture persists. A sterilizer load with mixed metal sets should be A. Separated by weight for even heating. B. Loaded tightly. C. Processed normally. D. Washed with bleach. Answer: A. Heavy and light sets should be grouped to avoid uneven heating. The presence of wet packs after cycles usually indicates a problem in A. Cooling, ventilation, or loading. B. Packaging only. C. Exposure phase. D. BI selection. Answer: A. Wet packs stem from cooling, loading, or ventilation issues. The air removal method in a gravity displacement sterilizer is A. Pulsed vacuum. B. Steam flush pressure pulse. C. Passive downward displacement. D. Mechanical ejection. Answer: C. Gravity units rely on air sinking and steam rising. A sterilizer's pressure gauge reads normally, but temperature is low. Cause? A. Superheated steam. B. Air leak. C. Scale buildup. D. Wrong cycle selection. Answer B. Air leaks reduce temperature even when pressure appears correct. A load considered non-porous includes A. Towels. B. Basin sets. C. Wrapped instruments. D. Textile packs. Answer B. Basins and metal sets are non-porous, allowing easier steam access. The final verification of sterilizer performance is provided by A. Chemical indicators. B. Mechanical gauges. C. Biological indicators. D. Packaging integrity. Answer C. BI results are the highest assurance of microbial kill and sterilizer function.